welcome to Trig Derivatives. So recall we've actually seen the derivative of two trig functions already. So first up, the derivative of sine of x is simply cosine of x. And the derivative of cosine of x is negative sine of x. So some other trig functions we have. Well, we have tangent. So if I want to find the derivative of tangent of x, it turns out that this is simply secant squared of x. So if I want to quickly see why, well, tan x is actually just sine x over cosine x. So we could go ahead and simply use our chain rule, or sorry, our quotient rule. We'll learn the chain rule next section. We'll use our quotient rule. So by the quotient rule, I know I do the derivative of the first, so the derivative of sine of x times the second, cosine of x, minus the first, sine of x, times the derivative of the second, so the derivative of cosine of x, all over the second cosine of x squared. And this becomes cosine of x times cosine of x minus sine of x times derivative of cosine is negative sine of x, all over cosine squared of x, or cosine squared of x plus sine squared of x, all over cosine squared. Cosine squared plus sine squared. This is equal to 1. That's our standard trig identity. So we simply have 1 over cosine squared of x. And well, 1 over cosine is secant, so 1 over cosine squared is secant squared x. So this is why this is true, but you can go ahead and simply use the derivative of tan x equals secant squared x as fact. So again, this is our first fact. The derivative of tangent is secant squared. Next up, turns out that the derivative of cotangent of x is simply negative cosecant squared of x. We could do a similar argument using the quotient rule to prove this one. The derivative of secant x actually winds up being secant x times tangent of x. Again, we could use the quotient rule. Secant of x is 1 over cosine. The quotient rule applies. And finally, the derivative of cosecant of x is equal to negative cosecant of x times cotangent of x. So again, These are all facts. So if we wanted to take the derivative of any of our 6 basic trig functions, we now can do so. Again, all 3 of these functions here, we could have used the quotient rule to prove these. We could have used the quotient rule to prove. All right, so let's just do a quick example. If I want to find the derivative of f of x equals 5 times the cotangent of x minus 3 times secant x. Well, this is the same thing as we have f prime of x equals, we can do 2 separate derivatives, right? So we'll do the derivative of 5 cotangent of x minus the derivative of 3 secant of x. Any constant or scalar multiples just come along for the ride. So this is just 5 times the derivative of cotangent was negative cosecant squared of x. And we are subtracting, we'll have 3 times the derivative of secant x was secant x tangent of x. And so all together, we wind up with negative 5 cosecant squared of x minus 3 secant of x tangent of x. So again, that's using our newly found trig derivative.